Before you start your secondary antibody incubation, here is a final reminder. If you are using a PVDF membrane, verify that it is fluorescence compatible. Otherwise, you risk high background and poor signal-to-noise ratio when it comes to detection. Hopefully you knew that already from the earlier course, equilibrating the gel and preparing for transfer, but if not, now would be a good time to refer back to it. As with primary antibodies, secondary antibodies should be diluted in the same type of solution that was used for blocking the membrane, but with 0.2% tween-20 added to improve specificity. Again, it's recommended to use a commercially available antibody diluent, such as Intercept T20 antibody diluent available from Lycor, for the purposes of consistency. Also remember that you can add multiple highly cross-adsorbed secondary antibodies to the solution for multiplex detection. That way, you do not need to carry out multiple separate incubations with different secondary antibodies. Remember that if your targets are the same or similar molecular weight, you should make sure to use secondary antibodies which are specific for the particular host species or subclass of the primary antibodies and not from the same host species as any of those primaries. If you are using a PVDF membrane, you should also make sure to add SDS to a final concentration of 0.01 to 0.02% to increase antibody specificity. But you don't need to do this if you're using a nitrocellulose membrane. As far as the dilution factor for your antibodies goes, you should always check with the manufacturer for their recommendations. But if you're using the IR-dye secondary antibodies from Lycor, the recommended starting dilution is 1 in 20,000. You can always optimize this dilution factor further in future assays if required. One last point to note is that dyes conjugated to secondary antibodies are sensitive to strong light sources, particularly direct sunlight. This can cause photobleaching, which is an irreversible reduction in the fluorescence of a dye. Because this could have a significant detrimental effect on your signals, you should always keep the blot protected from light as much as possible, from the moment the secondary antibody solution has been added. For example, you should use opaque incubation boxes, or if you don't have any available, simply wrap your incubation box in foil. To perform the secondary antibody incubation itself, once the final wash of the series following the primary antibody incubation has been completed, carefully pour off the wash buffer. You can then incubate the blot in the secondary antibody solution for 1 hour at room temperature with agitation. We talked about the importance of washing the blot in the primary antibody incubation course. But as a reminder, this is done to remove any unbound antibody from the membrane. First, you should pour off the antibody solution and then add the wash buffer, which will consist of either TBS or PBS with 0.1% tween-20 added. Make sure to pour this to the side of the blot and not directly on top of it. Quickly agitate the blot for 10 seconds and then pour off the wash buffer. This step is done to ensure that we remove any residual unbound antibody from the container. Next, wash the membrane at room temperature 4 times for 5 minutes and no more, always with gentle agitation. Lastly, be sure to rinse the membrane briefly in PBS or TBS without tween-20 to remove any residual detergent from the blot. Now we've covered the science behind the secondary antibody incubation step of the Western blot assay and the protocol for carrying out this step, in the next lessons my colleague Jessica will give you some tips and best practices to help you achieve the highest quality results. And in the next course, we will discuss the science behind detection of your signals and the best practices for this process.